This video is about how to evaluate or apply real numbers. We're in the context of beginning or elementary algebra. We're going to start with some examples where we understand inequalities, so less than, greater than, or maybe equal, for the following. Our first example is going to allow us to compare -5 with -7. We want to put the symbol in between these numbers that is fitting. In other words, is one of them greater than the other? Are they equal? And so on. Well, since they're both negative, we have to be careful about the number line. When they're both negative, it can be a little deceiving or easy to get turned around here. It turns out that -5 is actually less negative than -7. One way to think about that would be to imagine you losing money with these numbers. If you lost $5 or lost $7, which is better? Well, better would be to lose only 5 instead of 7. So actually -5 is actually greater than -7. Now regarding the inequality symbols, we want to think of them, the little caret symbols, as not arrows, but as hungry alligator mouths, okay, which sounds kind of childish, but it really works well. So think of the alligator wanting to eat the bigger number every time. Okay, well, as we just discussed, -5 is actually bigger than -7 because it's less negative. And so the alligator would be eating or trying to eat the -5, so the mouth will open up toward that number. Secondly, we want to compare in the same way -5/2, so -5/2, a fraction, with -5/3, -5/3. But you'll find quickly that it's harder to compare fractions, at least when they don't have a common denominator. So anytime we were going to compare fractions, we want to do the LCD work that we've already done, so this is nothing new here. A common denominator for these two fractions, having 2 and 3, would be 6. And so we're going to rewrite both of these fractions and kind of rewrite the whole problem, but use the common denominator of 6 with the new set of fractions. And like we've already been doing, that may require us to change the numerators as well. If you go back to the first fraction on the left, it was -5/2. Well, we turned that 2 into a 6, which means we would have multiplied it by 3. But we would have to do the exact same thing to the numerator. 5 times 3 up above them would give us 15. And let's not, of course, forget that this was a negative. Both of these fractions were negative, and they should stay negative even in this new comparison. If we go on to the second fraction, that denominator was a 3. We'd have to multiply that by 2 to get the 6, but therefore do the exact same thing to the numerator, which now would be a 5 times 2, or a 10. Once you have a common denominator with fractions, you can compare them simply by comparing the numerators. So the first numerator is -15, the second one is -10. It's a double negative comparison like we just did in the previous example, and so we'll find in the same way that -10 is less negative than -15, so the alligator would want to eat the bigger value of -10. Moving on to some others, our third example reads, we're comparing -π/2, okay, we're using this Greek symbol pi here, which represents a common number. You could approximate it with 3.14. You might have seen that in the past. So we're comparing -π/2 with -2.3. Now we're doing the same kind of thing where we're looking for the bigger number or smaller, or maybe they're equal, and we want to let the alligator eat the bigger one. So as mentioned, let's use the fact that pi is approximately 3.14, and we'll just jot this down here. So the symbol pi approximately means 3.14. It's a little more detailed than that in the actuality, but it's good enough to use for now, which means we could approximate this value π/2 by doing -3.14/2, and that could be crunched out on a calculator or even done by hand. But we're going to use that approximation to help us compare these two numbers. We're comparing that with -2.3, and again we're looking for the less negative number. If you crunch out -3.14/2, you'll end up getting a -1.5 and some change, which is certainly less negative than -2.3. which means the alligator will be trying to eat that value. So the negative pi over 2 is actually bigger than or greater than negative 2.3. And then on to our fourth example, we're comparing two numbers that are inside these straight vertical bar symbols. Let's recall that those actually mean absolute value. We'll be doing more work with that going on from here, but just as a remembrance, that's absolute value, which means the distance between that number and 0. So we want to compare the absolute value of 5/2 with the absolute value of negative 2.5. Well, you could also turn these numbers into a more convenient decimal form, as we've kind of been doing here. 5/2 is really 2.5. If you turn that into a decimal, just divide 5 by 2. So it's easier to compare that number, maybe as a decimal, with the other, which is negative 2.5. Now, they at first glance seem like they're on opposite sides of 0. One's positive, one's negative. But let's not forget that we're using absolute value here. So how far is 2.5 from 0? Well, it's just 2.5 units. So the absolute value of 2.5 is 2.5. Okay, moving on to the right side here. How far is negative 2.5 from 0? Well, it's 2.5 units from 0. Now, it's on the opposite side of 0, but again, absolute value simply means distance from 0, and so that's a fair way to crunch that number as just positive 2.5. So really we're comparing 2.5 with 2.5, and obviously those are the same numbers, so we'd have to say that those are equal.